Now let's move on to two-dimensional kinematics. 2D kinematics works using the same principles as 1D kinematics. The only difference here is that both vertical and horizontal motion must be accounted for. It is important to note that the acceleration due to gravity is 9.81 meters per second squared downwards. Now let's try a couple of practice problems. An object is shot from the ground at 75 meters per second at an angle of 45 degrees above the horizontal. How high does the object get before beginning its descent? Now first, let's start by drawing the scenario. We know the initial velocity of the object, and since this represents a right angle triangle, we can find out the vertical and horizontal components by using sine and cosine. Let's draw a table similar to our one-dimensional problems, but this time with the x and y components. We know that when the object reaches its maximum height, its velocity will be zero, as it would stop for a moment before descending again. We plug in the given variables into an equation that can give us displacement and solve for it. Number 2. An object is shot from the ground at 125 meters per second and at an angle of 30 degrees above the horizontal. How far away does the object land? Let's start this the same way we started the last problem and draw a diagram and a table with their given values. This problem can't be solved using just one equation. What we need to do here is to find an equation that we can plug all these values into while giving us one missing value. In this case, the one missing value we can solve for is time. V equals V initial plus A times t. The time we get from this is the time at which the final vertical velocity of the object is zero, meaning it reached the peak of its motion. If you imagine an object being thrown at an angle, this moment would be halfway through its path. This means that in order to get the total time, we must multiply this given time by 2. Once we get time, we can then solve for distance using our now known variables. We get an answer of 1379 meters.